Another measure of central tendency. What standard deviation does is it tells you how close or how far from the average the data actually is. So when you take the average and you find the numbers and you take the average of the numbers and then you choose a number, it'll tell you how far it actually is away from the number. Now there's a little chart that we make in order to find the standard deviation, and we just follow through the process. Now your calculators can do it. For most of you, the graphing ones certainly can, but we're going to learn how to do it without the calculator. So the first thing that we got to do is we've got to make a chart. So standard deviation is a measure of how spread out a data set is around the mean. A low standard deviation means that the data is close to the mean, or the average. A high standard deviation means that the data is scattered farther away from the mean. To calculate the standard deviation for a set of data with n values, square the difference of each data value x from the mean x. Use this expression as follows. Okay, so here's what happens. I'm going to just give you a sample one here. So you may want to write this down. Okay, so I'm going to take 10 test scores. Okay, so we'll do 8. Okay, so the x represents the actual value. So we set that in the first column of our chart. So the first thing that we're actually going to do is we're going to find out what the average is. This symbol right here means average or mean. So to find the average, add up the scores and divide by the number of them. So let's get your calculators out and let's do that. So about 1, 2, 7, I got 8 scores. So add them all up and divide by 8. 65.38. Okay, we're gonna just round that to 65.4 because we have to use this number a bit more. All right. So now, if this is my score and this is my average, what do you notice I'm doing here? I'm just subtracting. So I take this value here and subtract my average to get that value right there. Okay, so let's do that. So 42 subtract 65.4 is what?
Negative 23.4.
Negative 23.4. Okay. 46 subtract 65.4. Help out here. Use your calculator instead of holding on to it.
Negative 19.4.
Okay. Thank you, Lockman. 58 minus 65.4.
Negative 7.
Okay. 62. We'll do the easy ones. 64. 79 subtract 65.4.
13.6.
83.
17.6.
17? Yeah. Not bad. 17.6. Okay. And 89?
23.6.
23.6. Okay. So that's what this symbols mean. What do you think this now means? What's that?
That value squared.
That value squared. So let's do that. Minus 23.4 squared.
Negative 547.56.
Okay, first of all, it can't be a negative, right? Because you're squaring it. But just give me the number, though. That's good. Lachlan, what do you got?
547.56.
547.56. Good. Okay. The next number, 19.4 squared.
376.36.
376.36, good. 7.4 squared.
54.76.
3.4 squared.
11.56.
Excellent. 1.4 squared. 13.6 squared.
184.96.
Great. 17.6 squared.
309.76.
Good job, guys. And 23.6.
555.96.
5.96. Okay. Everybody's following along so far? Now what I need is this. Anybody know what that symbol means? You've seen this before? Doubt it. Means sum. Okay, that symbol means sum, add. So what am I looking for? The sum of all those values. So add them up right now. Look for the sum of all those values.
Okay, it's 556 what?
0.96.
Uh, 20,000, no, 2,043.88.
2,000.
43.88.
Anybody want to second that motion? Yeah, good. Okay, so now, the final thing I need to do now is, again, using the same symbols. Okay, so what does this look like to you now? What am I going to do? Judging by what you see up on the board for symbols, what do you think I'm doing right now?
Square root the average.
Square root what?
The average.
Not the average. The sum, that's right, of this divided by the number of scores that I have. So I take the sum, I take the square root of 2043.88 divided by 8. And what do I get?
15.98. 94.
Okay. That is what we refer to as our standard deviation, which means that my scores are fairly considerably spread out around the average score. That's what that means. Okay? Now, I usually take my time now and I go into a little bit of forward thinking with what we're going to use this for, so that you have a better idea as to why we do this. And what we're looking at is this. What we are going to end up working with is what we call the bell curve. Now the bell curve is used for a variety of things. The only thing that I can think of that was really where I've seen it used before is profs at universities will use the bell curve. And so they'll say they marked on the bell curve, which means that if they had a lousy average for an exam, they may move everybody up a standard deviation, okay, so that it doesn't look so bad. All right, so here's how the bell curve works. It's broken up into sections. This guy right here is your average, okay? So that's your average score. In this case, our average score was 65.4. Okay? One standard deviation above this. So the symbol for standard deviation is this little guy right here. Okay? One standard deviation above that. All right? Is 65.4 add 15.984. So that is, what is that? 81.384. Okay. One standard deviation below this is 65.4 minus 15.984. What do we get there?
49.14.416.
416. Okay. So, and I don't need you to, I just want you to watch this. Don't feel you need to take this down. We'll do this tomorrow. Or sorry, on Thursday. Okay? What this means is that if I'm looking at all of the scores, it says that 34% of the scores will still, bless you, will finish either below one standard deviation, or 34% of the scores will finish up 1%. So what does that mean? Okay, is if I take one standard deviation below and one standard deviation above, in this case, between 49% and 81%, that means that 68% of all the scores that I tabulated will fall in this range right here, between this score and this score. Well, looking at it right now, how many of those scores fall between 49% and 81%? How many? 4 of them only?
Yeah.
4 out of 8? Is that what you're saying?
Yeah.
Basically, okay? So that's a little less than what the 68% is. There should be more of that. But this is a large gap. That's a large standard deviation. All right? And then this whole thing breaks down. We go 2 below, and that is 14.5% more. And 2 above is 14.5% above. Okay? And then it goes a second one. So this is standard deviation of +2, standard deviation of +3 is 2.35%, I think. Just want to make sure my math is right here. Yeah. Okay. And then this would be 0.15%. So that would be all the way up to here, and so on. So what we're doing is we're finding this value that allows us to use this, what we call normal distribution graph. Okay? And this is a very important graph to use when we work with statistics. All right? It's called the bell curve. So what it does is it says this. All right, let's take, for an example of a question would be, all right, I have 1,000 batteries coming from the battery store. Okay? And out of those 1,000 batteries, I want to know how many will last longer than a certain amount of time. So they would take each battery, they would measure their amount of time, and they would put them onto a chart like this. And then it would say, okay, well, how many would last longer than this? Well, only 2.5% of them would last longer than that time right there. Maybe only 2.5% of them would go less than that percent right here. 50% of them are going to make it to the average. 50% of them are going to finish higher than the average. That's what this chart does. That's why we put the average down the middle, because 50% of all the scores are going to end up here, and 50% of all the scores are going to end down there. Okay? In this question, it didn't work all that well because 65 is right here, which means there should be 4 above and 4 below. But it wasn't. Okay? And it was skewed. Why was it skewed? Because there was a couple really low marks here and only 2 real high ones up here. And the rest were closer, were lower. Okay? But the more data we get, the better the results are going to end up. Okay? It's harder to do these questions with just 8 of them. All right? So for today, what you need to be able to do is use this chart and calculate what the standard deviation is. But there is a catch to it. The chart works well unless I have a frequency, unless I use a frequency table, which does change how we actually set the chart up. Okay? So we're going to take a look at that first example question, and I want you just to read through it. It says, determine the mean and standard deviation of the number of overtime hours to the nearest tenth. So Rhonda works in human resources at a car plant. She records the number of overtime hours worked in a month by 35 employees. Now, I told you yesterday that sometimes when it comes to a histogram or a frequency polygon, it's not easy enough when you've got like as many as there is here. There's 35 employees here, right? So to put those all on a graph would be a big graph. So what do? We find intervals that work for us. And then we find the frequency that the numbers occur in that. So if you look at the top of page 117, you have overtime hours, right? So you've got the OT hours. And they broke it up into intervals. So the first interval is 0 to 2, then 2 to 4, right? So yeah, so then 4 to 6, 6 to 8, is it 8 to 10? Yeah. And 10 to 12, okay. 10 to 12, okay. So now what they did is they found the frequency that occurred. So the frequency was, read those out to me, 6, 12, 10,
3, 1.
1. Okay? So that works out to be 35 employees, right? That's a total of 35 employees. Now what we do is we use, and this is the catch, this is the new part. This is not on the old graph, this is only for this type of graph. We have to find the midpoint of our display right here. So that is 1, 3, 5, 7, 9, and 11, right? That's the midpoint of our intervals. That's what we got to find next. Because what we're going to do is we're going to do our best to try and find out how many total hours that worked out to for each interval. So if 6 people work between 0 and 2 hours, and the midpoint is 1 hour, we just multiply f times x, and we get 6 hours here. Here we get 36, 50, 21, 27, and 11. Okay? Halfway between this number and this number.
Oh,
The midpoint of that interval. Okay? So when we add it all up, there's 151 total hours. So how do I get the average then?
Divide by 30.
Divide that by 35, that's right. And what does it work out to? There's my average, 4.3 hours. Okay? So far we all right? Okay, so that's just to find the average. So how do I find the standard deviation when I go through all of this? That's the next order of business here. And for that, I want to go a second here. And that one I'm going to pull back up. Okay. So. Oh, I don't want that one. That I want. Here it is. All right, still not the right one. There we go. Okay, so this is the last half of the chart that we need to have. So up to this point, we've done this part in here. So I take the midpoint. Now, this is similar to what we did before. I take the average minus this guy right here. Hold on a sec. Nope, I take midpoint. Where are we got here? Frequency, so that's 28. That's the average. And this is, oh, yeah, this value, your midpoint value minus my average. So, let's just go back to here. So now what I want to do is I'm going to take my midpoint score, and I'm going to minus, I wrote that, my midpoint minus my average. Okay, so this is what we did earlier. So 1 minus 4.3. So that is, what is that? Minus 3.3, right? So now I take 3 minus 4.3, 5 minus 4.3, 7 minus 4.3, 9 minus 4.3, 4.7, and 11 minus 4.3 would be 6.7. So there's my midpoint minus that. Now, that value there, okay, make sure that we got this right. Okay, so 3.3 squared is what?
10.89.
1.89. 1.3 squared?
1.69.
0.7 squared? 2.7 squared?
7.29.
4.7 squared?
22.09.
And 6.7 squared.
44.89.
Okay? We want the sum of this. What does that add up to?
87.34.
So to get my standard deviation, square root of, how many did I have? Out of 35. Take that out, no? Oh.
7.42.
Hello? I don't know. Good, good, good.
1.57.
Okay.
92556. I don't know, 1.57. 1.58.
Where'd you go?
Yeah, 1.576. 1.579.
Is the option Thursday night or Friday morning?
It's around 9.
1.58.
Yeah. Oh, 1.50.
Right, Friday morning. So why don't you start earlier on Thursday?
It's wrong again.
What?
What? Yeah.
Yeah.
Where do we get the 87 and your nurse's office?
All of that.
Oh. You're so funny.
Do that. You're telling me to lower your price.
Actually, I'm just gonna pass out on the bus. I'm just like slobbering everywhere.
What time do you want? 6:20? Yeah, it's fine. You got that.
What did you guys get on your gym test?
44.
89.
Failing
Yeah.
just now.
No,
House.
I'm not so
He's currently just
Kayla, how many times I've asked you, you're not gonna be off with kids.
What's your guys' tomorrow? I'm just saying. It's really hard to get closer.
No, you just think really.
Can you come sit here and tell me? Give me your glasses. Still can't see that.
That's what she
She probably said like 6:36. She must know you can also use that.
Okay.
There's cinnamon
So level, here's the lowest level of hearing. This is me.
The only problem is that people look at color.
Once you get on the test about yourself, when's your birthday?
Dun dun dun, we're starting to play on Thursday. I'm just kidding, I don't actually.
I bet you it's about to pass. No, I think it's about this turning. Coming here to find. It's Marshall's birthday.
Oh, so you're like, why do you even put that in? I'm so sad, I don't even know how I passed this test.
I got 69. She was 70.
I'm so mad when I get a 78. It's like, why didn't you bump it up to 80? Bailey, it was like,
She knows it would be so
oh
hard.
my god, yeah. I tried, like, that was hard, but anyway. One, the most active reaction I did, like, that we got from Marissa. Okay, so she marked 16 of my questions, marked 6 in the wrong, gave me 10 out of 10.
Same, like in. No, I don't.
No, literally, that's all she did, she just had to get 10 right.
I didn't get
I was like,
I only got 6 right, but she gave me 10 power.
She's so bad at excavating martial powers. She gave me 75 on my women's test. I was like, oh yeah, Callie, I forgot. You passed the women's
And obviously.
It's my favorite lip gloss. I can eat it like candy.
You're
not
I spent so much on it.
It tastes so good.
It's not because of my it's just tough.
I know, it's like your lips. Just like your lips the whole time.
Yeah.
God, just put candy on your lips. Oh, yeah, every time I put that on, I just try
Okay. So 87.34 is the sum of this, right? Okay, and then the n value is your 35, because that's what you started with over here. All right, and what do we get as an answer here?
1.580.
Which is a little bit different than the book, is it not?
That says 2.5.
Okay, so then there's, we need an error somewhere in here. Where's the error?
You have to lick it off.